Alright guys, in this video we're going to talk about orbital diagrams. Orbital diagrams are kind of cool, but you got to know how to do electron configurations before you can do orbital diagrams. So if you haven't watched the videos on how to write electron configurations, please do that first. Okay, now it's very important to be following along in your guided notes. Please have your Chapter 3 guided notes out and be filling in that information as we go through these slides. So, orbital diagrams, you have to write something here on your notes. Orbital diagrams use boxes to represent orbitals and arrows to represent electrons. So we use boxes to represent orbitals and arrows to represent electrons. So boxes for orbitals and arrows are the electrons. Remember, each orbital can hold how many electrons? Each orbital can hold a maximum of 2 electrons. So there's 2 electrons in an orbital. So each box can hold 2 arrows. Remember, a box is an orbital and an arrow are electrons. So 2 arrows in one box. Okay, we learned about the following orbitals. We learned about S, about P, about D orbitals, and F orbitals. There is one S orbital, so we will draw one box. Okay? Here's how I draw the S orbital, just with one box. Okay? There are 3 P orbitals, so we draw 3 boxes. Here's how I do it. I just make a rectangle and then divide it into 3 boxes. So you have 3 boxes there. Okay, there's 5 D orbitals, so we draw 5 boxes. I don't have much room here, but here's how I would draw the D orbital boxes. Just draw a longer rectangle, and now you've got to divide it into 5 boxes. Is that it? One more. So 1, 2, 3, 4, 5 boxes. Okay, and then there's 7 F orbitals. So this one, for the F orbitals, you're going to draw a really long rectangle and divide it into 7. So 1, 2, 3, 4, 5, 6, 7. Okay? Draw 7. Oh, here we go. Here's the example of orbital diagrams. So when you have to draw an S orbital, it's one box. How many electrons can fit in there? 2. So we're going to draw 2 arrows in there. I'll show you how to do that when we get there. The P orbitals. How many P orbitals do we have? 3. So you draw a rectangle, divide it into 3 boxes. Okay, the D orbitals. How many D orbitals do we have? 5. Okay, so we draw a big rectangle, divide it into 5 boxes. And finally, the F orbitals. There's 14 of the electrons that can fit in there, so we need 7 orbitals. Draw a big, huge rectangle, and make sure you have 7 boxes. Okay, if you look at the periodic table, you'll notice how many elements across is the S orbital? 2 elements. And those represent the 2 electrons. So now count across the P block, guys. How many elements are across that P block? Well, there's 6 elements. So how many electrons total can fit in here? 6, and so we've got to have 3 boxes, 3 electrons, and so forth. How many elements are across the D orbital block? There's 10. So if there's 2 electrons in each orbital, that means we need to have 5 boxes. And there's 14 across for the F, so we've got to have 7 boxes. Anyway, that's where those boxes come from. Okay, let's review the rules for orbital diagrams. We kind of talked about this when we talked about electron configuration. But there's an Aufbau principle which states that each electron occupies the lowest energy orbital available. Okay? You don't have to write this in your notes, but let's just review it. Okay, then there's the Pauli exclusion principle, which states that a maximum of 2 electrons can occupy a single orbital, but only if the electrons have opposite spins. We'll show you how to show that the electrons have opposite spins here in a second. And then there was Hund's rule. It states that single electrons with the same spin must occupy the equal energy orbital before additional electrons with opposite spins can occupy the same energy level orbital. This will make sense as we go through some of these example problems. Okay? So example problem number 24. Be following along in your book. We're going to do part A first for hydrogen. I think it's very helpful, guys, hey? It's very helpful to draw the electron configuration, write the electron configuration for it first. Help me out. What's the electron configuration for hydrogen, which is right here? 1s1. Please write that. That's not our answer, but that's going to help us get our answer. Okay, so here's the answer. Here's the orbital diagram. I want you to, how many boxes for the s orbital? 1 box. So I want you to draw that box, and underneath it I want you to put 1s. That's the 1s orbital. And then, does it have an electron in that orbital? Yeah, how many? Just 1. That's what this exponent is saying. So how many arrows do I need in there? Just 1. You're going to draw an arrow with it pointing upwards. The arrow is pointing straight up. Okay? And that's our answer. Circle that. That's our orbital diagram for hydrogen. Okay, let's go to helium. Okay, help me out. Helium is right here. Let's write the electron configuration first. What is it? 1s2. So if we write the orbital diagram, how many boxes in the s orbital? 1. So I'm going to draw 1 box and put the 1s orbital underneath it. We're labeling the box. Okay, now we've got 2 electrons. So 1 electron is spinning one way, and the other electron is spinning the other way. That's what Hund's rule was saying. And also the Pauli exclusion principle says they spin opposite directions. So that's how you show one is spinning one way, the other electron is spinning the other way. And there's our answer. Okay. Okay, lithium. Let's write the electron configuration real quickly. Here's lithium. Help me write it. What is it, guys? 1s2, 2s1. Okay, now I need to draw a box for the 1s, and I also need to draw a box for the 2s. How many boxes for the s orbital? 1 box. So put a box here and call it 1s. And then I need another box for the 2s. Always label the boxes. Okay. Now, let's fill them. Is the s orbital full? Yeah. So we're going to start there with Aufbau principle says we always fill the lowest one first. Pauli exclusion says they have to have opposite spin. So one goes up, one goes down. Now we can move on to that second energy level. How many electrons in this one? Just 1. So we just draw it with an arrow up. That's your orbital diagram for lithium. Let's go to practice problem number 25 now. Part A for boron. Guys, boron is right here. So let's write the electron configuration for boron. Help me out. Let's go fast. What is it, guys? 1s2, 2s2, and then we come across. What is it next? 2p1. Okay. So this kind of tells us the boxes. We need a 1s box, we need a 2s box, and we need a 2p box. So here we go. How many boxes for an s orbital? Just 1, so we're going to call it 1s. We've also got a 2s. Okay, now here's where it gets a little different. This one has a 2p level. How many boxes for the p? 3. So draw a longer rectangle Draw a longer rectangle and divide it into 3 boxes. And we're going to label it what? 2p. Now let's fill the electrons in. Is the first 1s orbital full or what? What do I write? 1 up, 1 down. They got to have opposite spin. Good job. 2s is also full, so one's going up, one's going down. Now the 2p only has 1 electron, so we're going to take this first orbital and put 1 electron in it, spinning up, and that's it. Okay, that's your orbital diagram for boron. Okay, very good. I'm going to give you a second now to do oxygen. So if you're watching the video, write the electron configuration, then write the orbital diagrams for oxygen. Once you have an answer, hit play and we'll see if you get it right. Right. Okay, so we're doing oxygen, which is sitting right here on the periodic table. Let's write the electron configuration first. So we got 1s2, 2s2. Come across, we're still the second energy level, P, and 1, 2, 3, 4. And you put a 4 up here. All right, now we've got a 1s orbital, we have a 2s orbital, and a 2p orbital. Let's draw the boxes. How many boxes for the s?
4.
Just 1, so I'm going to draw this one for 1s. But I also have a 2s, label it. And how many boxes for the p orbital? 3, so draw a rectangle and then kind of divide it. Okay, and label it 2p. Now let's go through and fill the electrons. The first energy level, 1s, is full. One electron is spinning up, the other one is spinning down. Okay, 2s is full. So we've got 1 going up, 1 going down. Now this is the point where I want you to pay attention because this is where we use Hund's rule. Hund's rule says you got to have half-filled orbitals first, and before you can completely fill one. So here's what you do. You draw an electron in the first orbital, in the second orbital, and in the third one. You're half-filling them first, before you can go back and completely fill them. Now I've got 4 electrons in that 2p orbital. Now, since all of them are full, we can come back and completely fill the first one. Okay? I want to talk about this Hund's rule. Why does that exist, guys? Do electrons, think about their charges. Electrons are negative, right? If I had 2 electrons right here and I brought them close together and I let go, what are they going to do? If they're both negatively charged, they're going to repel, aren't they? They don't like each other. They want to move as far away from each other as possible. So we half fill the orbitals first. No way do they want to be in the same orbital if they don't have to be. So you only come back and completely fill them after they are all first half filled. Does that make sense? That's what Hund's rule is saying. Anyway, that is our answer. That is the orbital diagram for oxygen. Okay, knowing that, let's see if you can do sodium by yourself. Sodium, okay? It's sitting right here on the periodic table. I'm going to hit pause. You guys should too. Try it, see if you can get it right, then hit play. Okay, so sodium. What always helps me, guys, is writing the electron configuration first. So sodium sits right here. Let's write it. 1s2, 2s2, 2p6, and then 3s what, guys? 3s1. Okay, so it looks like I'm going to have a 1s orbital, 2s, 2p, and 3s. So let's draw the boxes first. How many boxes for the 1s? Just 1, and put 1s under it. How many boxes for the 2s? Just 1, and put 2s. How many boxes for the 2p? 3. So draw a longer rectangle, divide it into 3, and put 2p. How many for the 3s? Just 1, and put 3s under it. Okay, the alphabet rule says you start from the lowest energy level first. Okay? Pauli exclusion says they have to have opposite spin, so we're going to put a down arrow. Okay? Then we move up to the second energy level, opposite spin. Okay, now watch as I fill the 2p orbitals. Can I put another one in this box right here, guys?
Yeah.
Right now?
Well.
No. Remember, Hund's rule says they're half filled before you come back and completely fill them. So watch what I do. They don't like to be by each other. So if there's another open room, they're going to take it. This orbital is like a room. So half fill them first. Now that there's 3, well, I got to get to 6. Now that they're all half filled, let's go back and completely fill them. Okay, that was Hund's rule. That's what it's saying there. If they can get their own room, they're going to take it. Yeah.
Wait, so why does the 1s only, or why does the 1s have 2?
Because there's 2 electrons in that 1s orbital.
Okay.
Yeah. Okay, now we've got the 3s. How many electrons in it? Just 1, so that's how you do it. Half filled. Okay. How many of you guys got that right? Just curious. Very good.
It's never, the arrow's pointing down.
What's that?
Like, so if it's alone,
Uh-huh.
why doesn't the arrow ever point down?
I guess you could put it down. It's just arbitrary. It doesn't really matter. The point is they're opposite spins. If they're in the same orbital, they have to have opposite spins. So, I mean, that's just convention. Most people would just draw the arrow up first. Good question. Okay, 26. Let's go to practice problem 26 and do A, B, C, and D, and then we'll be done. Okay. So, this one's a little different. It says, using the noble gas abbreviation method, write the orbital diagrams for the following atoms. Yes, you can do a shortcut on orbital diagrams. So let's watch and see how we do that. Let's first write the noble gas abbreviation method for chlorine. Chlorine, guys, is sitting right here. What's the preceding noble gas to chlorine? Neon. So I'm going to put neon in brackets. And then help me out. Let's go fast. Build the electron configuration from neon. What's next? 3s2. Whoops. 3s2, then what? 3p. And it's the 1, 2, 3, 4, 5th one over. Great. That always helps me know what to draw. You still need to put Ne in brackets, guys. So put Ne in brackets. And it looks like we have a 3s and a 3p orbital. How many boxes for 3s? Just 1. How many boxes for the 3p? 3. Is it 3s full? Yes, so opposite spins. Now watch how you fill the 3p. Hund's rule says that they're going to occupy a single half-filled orbital before they are going to be completely filled. We've got 5, so these first 2 orbitals are going to be completely filled. The last one here is just half-filled. That's it. Shortens it up quite a bit. Okay. Have we done any for the d orbital or for the f orbital yet? No? Okay, let's try one with a d orbital in it. Okay? This is iron. What's the preceding noble gas to iron? So iron's sitting right here. The preceding noble gas would be what? Argon. Ar in brackets. And help me build the electron configuration. What would I put next? 4s2, then what? 3d6. Okay. So yes, you still need to put the preceding noble gas in brackets. And now let's do the orbital diagrams. We need a 4s and a 3d. How many boxes for the 4s?
1.
Just 1. And label it underneath 4s. Now, this is our first one with a d orbital. How many boxes for the d orbital? 5 boxes. So you're going to have to draw a pretty long rectangle here and divide it into 5 boxes. 1, 2, 3, 4, 5. And we're going to put 3d underneath it just to label it. Okay. Is the 4s full? Yep. So 1 is spinning up, 1 is spinning down. Now 3d has 6 in it. Remember Hund's rule, we're going to half fill them before we come back and completely fill them. How many are going to be completely filled in this case? Just one, right? So this first one is full, and the other 4 there are going to be half filled. That's the orbital diagram for iron. Okay, very good. Okay, let's try it for silver. I'm going to hit pause on the video. Please write the electron configuration for silver. Again, we're using the noble gas abbreviation. And then write its orbital diagram and see if you can get this one right. And then hit play when you're ready. All right, for silver, guys, I'm going to point out where silver is. It's 47. Its symbol is Ag. It's right there. So the preceding noble gas, what did you guys get the preceding noble gas to be? What is it? Krypton. So Kr. Okay, very good. So we're going to put Kr in brackets here. And then help me with the electron configuration. Shout it out. What would you write? 5s2, 4d. How many over is it? 9? Okay. So that's the electron configuration. Now let's do the orbital diagram. We still need Kr in brackets, guys? Yes. Looks like I have a 5s and a 4d. How many boxes for the 5s? 1 box. Put 5s underneath it. How many for the 4d? 5. So yeah, draw a pretty long rectangle here. We're going to divide it into 5 boxes. Okay. And we're going to put 4d under there. Hey, is 5s full? It is. So we have 2 electrons, one spinning up, one spinning down. 4d has 9. Hund's rule, got to pay attention to it. Half fill the orbitals before you come back and completely fill them, right? So there's 5, 6, 7, 8, and 9. And yeah, that leaves 1 orbital here. That's just half filled, and that's okay. That is the orbital diagram for silver. Have we done one with an F orbital in it?
Not yet, but we're going to right now.
That's right. That's right. Let's try it. Okay. Thanks, Jagger. So let's do one with an F orbital in it. Californium. Okay? Hey, let's do this one together. Californium. It's sitting down. What is the atomic number of californium? 98. So it's sitting down at the very bottom. Let's see. Where is it? Right here. I can't hardly see it. Okay, there's californium. Its number is 98. So what's the preceding noble gas, guys? Rn. So we're going to put Rn in brackets. Rn in brackets. And then let's write it from there. So we're done here. Let's go to the next energy level, which is 7. 7s2. Now be careful right here. The 2 asterisks are telling you to drop down to here. What energy level? 5f. And how many over is californium? 10? Take your word for it. 7s2, 5f10. Okay, now do I still need to write the preceding noble gas in brackets? Yes, I do. So, yep, Rn. And it looks like I have a 7s orbital and a 5f orbital. If you want to hit pause on the video and see if you can do this one by yourself first, let's try that. Okay, hit pause, and when you're ready, hit play and see if you got your answer right. Okay, so let's see if you got the the orbital diagram for californium. Okay, we've got our preceding noble gas in brackets. How many boxes for the 7s orbital? 1 box. Okay, I'm going to draw 1 box and put 7s under it. How many for the 5f? Yeah, this is a new one, so 7. So draw a really long rectangle here. How many boxes do you got to have here? 7. So 1, 2, 3, 4, 5, 6, and 7. So this, I'm going to label 5F. Okay, let's go through and just fill the electrons. 7s is full. They have opposite spin. Now pay attention to how you fill the F orbitals. Okay, Hund's rule says they're half filled first. So there's 1, 2, 3, 4, 5, 6, and 7. Okay, how many do I have total in the F orbital? 10. If I've already got 7, then this is 8, 9, and 10. So 3 of them are going to be completely filled, and 1, 2, 3, 4 of them are just half filled. And that's okay. So there's your answer. Hey guys, did we learn how to write orbital diagrams?
Yes.
Okay, let me just review what you do to solve these problems. If I were you, please listen. I would write the electron configuration first. Then I would draw my boxes. So write the electron configuration first, then draw the boxes. And then go through and fill. If you've got, how many electrons in each box total? 2. Do they have to spin opposite directions? Yes. How do we show that? One goes up, one goes down. How many boxes for the S orbital? 1. How many for the P? 3. How many for D? 5. And how many for F? 7 boxes. Okay. Now you can do, guys, hey, in your student workbook, you now have enough information to get the orbital diagrams worksheet done. Okay, so that'll give you some more practice. If you want to watch the video again, you sure can. Hopefully this helps. So go and get your orbital diagrams worksheet done.